Hey guys, this is Kerry, and welcome to the first lesson in remote learning. So, as much as possible, your teachers are just going to be trying to create the same learning experience that you guys have gotten used to in class, and not let this pandemic kind of get in the way of any learning that you guys were hoping to do this year. So here we go. Lesson 1, Unit 11. So we're skipping Unit 10 for now because Unit 10 is all about calculator skills, and it's probably one that we should be doing with the calculators in class. So we're going to be doing Unit 11 trigonometry, and if you're curious how you can get credit for these videos or for your lessons, what you're going to do is you're going to actually take notes along with the video. The ideal case would be if you could print out the PDF that you were sent. However, you can't print out the PDF because you don't have a printer at home or for whatever reason, then you can take notes on some loose leaf paper. Try to keep your notes organized. You want to have your name, lesson 1, the lesson title, the do now. And when the problems are short like this one is, you want to write out the problem. But if the problems get a little bit longer, you can just write the problem number and then show your work next to it. So what you're going to be doing, whether you do it on a PDF that you printed out or loose leaf paper at home, is after you're done taking your notes, you'll take a picture of them and you'll send your notes, and that way you can earn your checkpoints and credit for completing the lesson. So of course there are going to be some hiccups in this system because it's new for all of us, but I'm excited to try this. I think it could be interesting and it could be a good learning tool. So here we go. This is going to be lesson 1, right triangle trigonometry. So triangle ABC is a right triangle where angle A is a right angle, AB is 9, BC is 41. Determine the length of side AC. So triangle ABC is a right triangle. So we can draw any right triangle that we want. But the key thing is it has to be a triangle and it has to have a right angle. And we show the right angle using a box here. Now very important, it tells us that angle A is the right angle. So we'll put the letter A here for this vertex. We don't know anything about angles B and C. But if you remember back from geometry class, your types of angles, C and B are both smaller than our right angles, so these are called acute angles. Next up, let's label the remaining given information. AB is 9, BC is 41. So, determine the length of side AC. And since we don't know it, we could call the length of this side x. So we're looking for a way that we can connect the three sides of a right triangle. And if you haven't solved this problem yet, pause right here and give it a shot. I think it will make more sense when we come back to review it if you've tried it once yourself. Okay, so hopefully you paused it and you tried it. Many students, when they try this problem, they immediately remember from Algebra 1 sine, cosine, and tangent. Well, you guys are way ahead of the game. We're not going to be talking about sine, cosine, and tangent yet because these involve, you need to know an angle for these. And when I say we need to know an angle, that's really shorthand for saying we need to know the degree measure of one of our acute angles. We need to know an acute angle. Having the 90-degree angle here is not enough to use those. All right, so if we can't use those, what can we use? Well, there's a famous formula that connects the three sides of a right triangle. And the famous formula is the Pythagorean theorem. And so the Pythagorean theorem is something that you may have seen before, hopefully. If you haven't, it's a formula that says a squared plus b squared is equal to c squared. And when you're thinking about these letters, A, B, and C, those are going to be the sides of the triangle. Now, the most important thing to remember is that C is the special one because it's over here by itself, and C is always the hypotenuse of the triangle. Now, the hypotenuse of the triangle is always the longest side of the right triangle, and it's also the one that's directly across from the right angle. So the right angle kind of points at it. So our hypotenuse in this case is going to be 41. So we plug in 41 for C, and then we square it as per the formula. Now for A and B, either one of these can be A, and the other one will be B. So we get x squared plus B is 9 squared. Now we get x squared plus 9 times 9 is 81. 41 times 41 might not be as easy. So as a calculator, when you're at home, you can always use www.desmos.com. If you have the luxury of working on an iPad or your iPhone, they have a really nice app. And you can just go to that, and you can do 41 squared, and that gives you 1681. Subtracting 81 on both sides gives us x squared equals 1600. Taking the square root of both sides, if you see it, you don't have to use Desmos, but you can go to Desmos and do it here also. Square root, clear it out, square root 1600. That's 40. And so we get x equals 40. So our missing side was actually 40 units long. All right, so hopefully that's a good example of what these videos are going to be like. I sometimes talk a little bit fast. So if I talk too fast, feel free to rewind the video. Feel free to slow the video down by clicking on the button that looks like this. It's like the settings button, and you can make me speak in slow motion. Feel free to pause the video. Feel free to skip ahead in the video if you feel like you know something, but then if you don't know it, make sure you rewind it. Also, make sure you listen to the videos with sound on, because that way you can actually hear the important narration as you go through. And just as a joke, don't forget to like and subscribe, but actually it doesn't matter, it's just a joke. So today's lesson is actually not about the Pythagorean theorem, but it's about kind of this idea of when you have a triangle and you know three things about it, how can you find the other thing? So we're actually going to be returning back to the sine, cosine, and tangent idea. So the way that sine, cosine, and tangent work is you're going to be given some right triangle, and you can draw this however you want as long as it has a right angle. There's going to be three angles, so you can give them any letters you want. I used A, B, and C before, so I'm going to use D, E, and F this time. So unlike the Pythagorean theorem, where we started off with the three sides, in this case we're going to start off with one of the angles being given to us, so that would be angle F. Now the second you have angle F, it actually gives you a focus point to label all of your sides. So in the right triangle, once you pick a focus angle, you can label the sides as follows. We know that the hypotenuse is always going to be directly across from the right angle. So this pink side right here, that's going to be the hypotenuse. It's also the longest side. The other two sides are now special, actually. Before, they didn't matter for the Pythagorean theorem, but opposite from the F angle is the opposite side, because it's directly opposite from F. If we had chosen D, we would have had a different opposite, because it's all based on our angle, but we chose this angle, and so our opposite is opposite from it. Now, the hardest of the sides to label is the remaining one. It's a word called adjacent, and in English, adjacent means next to, and it's because this green side is next to the angle. What's confusing about that, though, is the hypotenuse is also next to it. So I like to always label this one last, because it's just going to be the leftover side. Eventually, you'll start to see these pretty quickly, and you won't have to worry about labeling them in an order, but I always think of it as hypotenuse is the easiest to label, then the opposite, and finally the adjacent. All right, so how are these four things, the angle, hypotenuse, opposite, and adjacent, all related to each other? Well, they're related with three different formulas, and you've got to pick which tool to use depending on which case you're given. So here they all are. Sine of the angle. So you'd be plugging in the angle into some function sine. And that is equivalent to, always going to be equivalent to, by definition, the opposite side, and that's going to be some number divided by the hypotenuse. Next up, we have cosine, and cosine is going to be cosine of some number, and you can find these buttons on your calculator. That number is going to be your angle, and it's always going to be equal to the adjacent divided by the hypotenuse. And finally, right next to this on your TI-83s if you had them, or right next to it probably on Desmos, is a function called tangent. And when you do tangent to your angle, it gives you the opposite divided by the adjacent. So before we use these to find any missing values, we're going to work on a couple of problems where we try to find them for each of these trig problems, or each of these triangles. So the most important thing to realize is the labeling here changes depending on what angle you're focused on. So for problem 1, looking at the problem, we're going to be focusing on angle A, so we mark it right away. Now the second we mark angle A, we're able to label all of the sides. With our right angle here, that makes this the hypotenuse across from it. Because we labeled our angle as A, opposite from that is our opposite. And finally, the hardest one to label is the adjacent, but in this case, it's the last one there because we were strategic in how we labeled these things. So we've got the sine of angle A, and the sine of angle A is always going to be equal to opposite divided by hypotenuse. So the sine of A is going to be opposite divided by hypotenuse. And that's all we have to do for this problem, is just write down what it equals. The cosine of A, we look at our formula, it's adjacent divided by hypotenuse, so it'll be adjacent divided by hypotenuse. And for tangent, let me put these in boxes so they look separate from each other. And for tangent, it's going to be opposite divided by adjacent, so we'll have 7 divided by 24. Now, problem 2 looks like the exact same problem, but in this case, if you look at the problem, our focus angle switches to B. And so you want to mark B right away. Now give it a shot to see if you can label your 3 sides using the vocabulary words. Always start with the hypotenuse, because that should be the easiest. Then do the opposite. Then do the adjacent. All right, so pause here and see if you can do that on your picture. And after you do that, see if you can do sine, cosine, and tangent. At this point in class, I would have said something like, turn to the person next to you and see if you can figure it out. All right, so hopefully you paused. Here we go. In order, hypotenuse is still the one across from the right angle, so still 25, the longest side. Opposite is now changing because opposite from B is 24. And adjacent is now this one. So now it's important after labeling these that you construct the ratios correctly. So sine is opposite over hypotenuse, so that's going to be opposite over hypotenuse, 24 over 25. Notice that sine is not the same. So when we change our focus angle, it actually changes all of these ratios. Cosine of B is now adjacent over hypotenuse, 7 over 25. And tangent of B is now opposite over adjacent, so 24 over 27. So all of, oh, sorry, not 27, 24 over 7. All right, so all of them are different. Perhaps you've noticed a pattern. Perhaps, I don't know. It's a pattern that I'm not going to be emphasizing, but maybe you notice some relationship between the two of these. All right, so where the main focus of our lesson comes down to is using this information to determine the value of x on these triangles. So what you'll notice immediately when you look at them is the Pythagorean theorem is not sufficient here because we don't have information about the 3 sides of the triangle. So because we can't use the Pythagorean theorem, we're going to try to use something relating this angle to these 2 sides. So this problem actually tells us our focus angle right away. Our focus angle is going to be this blue angle here, 67. Once we label that as our focus angle, it immediately implies the vocabulary we should be using to label the sides. So across from the right angle is the hypotenuse. Opposite from our focus angle is the opposite. And the hardest side to label is the adjacent, which will be the one left over. So now what we're looking for is, we know 67 is our angle. We know the hypotenuse is 18. We know the opposite is x. So we're looking for a formula that relates these 3 things. And because we don't know anything about the adjacent side, like how long it is, or anything else about it, we don't really want to find it because it's not labeled x. We're going to cross this one out, and we're going to look for a formula that only has the opposite, hypotenuse, and angle. So we go up to our 3 formulas, sine, cosine, and tangent. Which one has the opposite, the hypotenuse, and the angle? Opposite, hypotenuse, and angle. So it looks like it should be sine. let's just do a brief check with cosine and tangent. We know we can't use cosine because we're trying to avoid the adjacent, since we didn't know anything about it. And tangent also involves the adjacent, so we don't use that one. Sine has everything we need without the adjacent. So sine of the angle is equal to opposite divided by hypotenuse, using some abbreviations for our formula. Now plugging everything in, we get sine of 67 is equal to x divided by, I wrote all over it, sorry, it says 18 there. And you're just plugging in the values from the picture. Now, really important, sine of 67, this is just some function, something mathematical that we're doing to the number 67. And you can use Desmos or any calculator to do this. So let's pop over to Desmos and see if we can do it. Now, it's really important that before you do this, we need to make sure our calculator, because our angles are measured in degrees, it needs to be in degree mode. Later on, we're going to learn about something called radian mode. But for degree mode, let's take a look at Desmos and see how we do it. We click this little tool thing, I believe. Yes, and here it says radians are selected. Change that over to degrees. All right, so now we should be good. To find the sine function, you go into functions, click the trig menu if it's not already clicked, and do sine 67. Just make sure. Yeah, that is degrees, so that gives us 0.9205. And I'm just going to do a check to make sure that's degrees with one that I know. This should be a half. Yeah, it is. Okay. So sine 67, that is correct. 0.9205. And I always take 4 decimal places for these. So this is 0.9205 using our calculator equals x over 18. And now this is no longer a geometry or trigonometry problem. To solve for x, you multiply by 18 on both sides. And we get x is equal to, going back to Desmos, you can just do times 18 here and get 16.6. I'm going to round to the nearest tenth. Now, a check you want to do is, does it make sense that x is 16.6? Yes, because it's less than the hypotenuse. And we already know the hypotenuse should be the longest side. All right, triangle IMY is a right triangle with right angle y. Wow, that's a touch of a bad picture. Please do not draw terrible pictures like I just did. With right angle y, angle M is 43 degrees. It could be either one of the acute angles. I'm not sure which one, but you can label it wherever you like. The right angle is the one that you have to put in the right spot, and then the other one is I, so I'll put I here. YI is 14. Determine the length of side MY, so we'll put an X here for that one. All right, so we need to figure out which of our 3 formulas, sine, which is opposite over hypotenuse, and I'm just abbreviating all of these, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent. Which of these we need? So we've got our angle automatically given to us, which means this is going to be the hypotenuse. If we start at our angle and we go opposite, we hit 14. So this will be our opposite, and this will be our adjacent. So looking at our sides, we want a formula that involves opposite and adjacent, but does not involve the hypotenuse because we don't have a variable here. We don't have a variable here. We don't have a number. Oh man. We don't have a variable here or a number here. We just don't want to use the hypotenuse. In fact, I'm not going to mess with that anymore because it's just keeps getting worse. So we want opposite and adjacent. Sine is opposite and hypotenuse, cross it out. Cosine is adjacent and hypotenuse. We don't want hypotenuse, cross it out. Tangent is opposite over adjacent. That's the one we want. So we write down our formula. Now the most common error that students make is they forget to put the angle here. Make sure you put your angle 43 degrees equals opposite over adjacent. And this one's a little bit trickier to solve because x is in the denominator. But before we get there, tangent to 43, that's an operation being done to a number. There's no variables there. We can just use our calculator to find it. So we go over to our Desmos calculator. Still in degree mode, good. And then over here we put function's tangent 43 to get 0.9325. Now this is kind of an accident that it's such a similar number to the last one. That won't usually be the case. So this is equal to 14 over x. Now to solve for x from here, you have to get x out of the denominator. The opposite of dividing by x is multiplying by x. So we multiply by x on both sides, and that gives us 0.9325x equals 14. Now the last step to solve for x is you divide by 0.9325 on both sides. And it's important to get the order of this division correct when you enter it in your calculator. So x is equal to 14 divided by 0.9325. So 15.01, or rounding to the nearest whole number here because it's so close, 15. Now, that's pretty cool. All right, so at this point, it's important for you to try this stuff on your own. So you're going to have the opportunity to earn 4 checkpoints. So you've got checkpoint 1, or sorry, I think it's 3 checkpoints now. Checkpoint 1, please do problem 2, even though it's not a checkpoint problem. It's important practice, and you should send that in your picture. Problem 3 is checkpoint 2. Problem 4 is not a checkpoint, but it's important to do. And problem 5 is a checkpoint problem that's pretty challenging. So we're going to actually record this one in case you guys need some help with it. But before you look at any of, and the tough stuff, of course, this is always going to be optional. You don't have to do this, but you do have to do all of the other problems. All right, so before you continue on, try every one of these problems on your own. You can look at the PDF if you need to see a picture of these problems, even if you're not able to print it out, and that way you can try the checkpoint ones. Make sure that you have the picture drawn, label the sides, and then create the correct formula out of sine, cosine, and tangent. So pause now, and please do these problems on your own. And then when you're ready, you can come back, and we'll look at problem number 5 together. Okay, so hopefully you got these problems all set. So for problem 5, anti-aircraft guns are stationary guns placed on the ground. They are used to destroy enemy planes during war. A plane is some distance away from an anti-aircraft gun, and flying away from the anti-aircraft gun, maintaining a constant altitude of 6 miles above the ground. You know, this is a lot to follow, so I think that it will be helpful to draw a picture here. So I don't actually think I've ever seen one of these in person, but if you played some video games, you may know that an anti-aircraft gun kind of looks like a little cannon, and it has like a little tripod, and it shoots up at planes. So here we go. We're going to have our little cannon anti-aircraft gun shooting up at a plane that's flying by. Okay. So the plane is maintaining a constant altitude of 6 miles above the ground. And actually, you know, I could draw that 6 miles right here, but thinking about the skills that we've learned in this lesson, it probably makes sense to draw that 6 miles coming straight down from the hypotenuse, or that diagonal, 6 miles right here. The barrel of the anti-aircraft gun is set to always track the nearby plane. If the angle of elevation between the barrel of the gun, so the barrel of the gun, and the ground, that will complete our triangle, this angle is always 40 degrees, then draw a diagram of the situation. Okay, we've got a diagram. What is the distance measured straight through the barrel of the gun to the plane? So that distance, I probably shouldn't use green. That distance is this blue distance right here. Straight through the barrel of the gun to the plane. And I'll call that x because that's what we're looking for. So this is actually now, if you can kind of erase the plane out, and you can see that's just a trig problem in disguise. You know the angle here, so immediately we go to label the sides. So this is our hypotenuse because this is our right angle. Opposite from the given angle is 6. And this would make that adjacent. So we're looking for a formula that has the adjacent and the hypotenuse. So we have so, this is often said so, ka, toa, this abbreviation. And in order to figure out which one we need, we're trying to avoid the adjacent, so we cross out any of them that have a, and it looks like we're using sine again. So sine of the angle, 40 degrees, is equal to opposite over hypotenuse. And so to solve this for x, we jump over to our Desmos calculator, sine of 40. Delete everything first. Function sine 40. Making sure always that we're in degree mode for now. So 0.6428 if we round it. 0.6428, 0.6428, 0.6428 is equal to 6 over x times x on both sides. That gives us 0.6428x is equal to 6. We divide by 0.6428 on both sides, and that gives us x is equal to 6 divided by 0.6428. 6 divided by 0.6428, 9.33. And because this is an applied problem, we want to try to use units. Since this was 6 miles, this is going to be 9.33 miles. Again, checking this with our diagram, this was the hypotenuse that we just solved for, so it should be the longest, so that feels like the right answer. All right, continuing on. There is another part to today's lesson, and then you guys get the chance to earn your final 2 checkpoints. So let's take a look at that together here. Solve each of the following equations for the variable. So this one, e to the x equals 50, should be very familiar from our last unit. We learned in the last unit that to cancel out base e raised to a power, we use a special operation called ln, the natural log. So in order to cancel out a base e, we do ln to both sides. That gives us x equals ln of 50. X is equal to, and we need Desmos to do this. So here we go, delete, 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 functions, no longer trig function, stats, nope, distributions, nope, miscellaneous, yup, ln 50, I think, 3.912. Cool. All right, so with trigonometry, you can take 2 different views of it. It's either a very geometric thing involving right triangles, or if you take the algebraic view of it, it's simply something that you can do to a number to get another number. So whenever we define functions in algebra, like base e, we always wanted to find out what was the opposite function, because that let us solve for variables within that expression. So the same way here, we want to get a by itself, so we need to know what's the opposite of cosine. And the opposite of cosine looks very similar. It's called cosine inverse, and it looks like this. And so these cancel each other out. So if you want to cancel out cosine, we do cosine inverse on both sides. Cosine inverse and cosine are opposites. They cancel out, leaving us with a equals cosine inverse of 0.5237. Now, we don't know how to compute this. This is some mystery operation. It's very similar to what we did with base killer, though, where when we had to introduce an operation, we always wanted to have an opposite thing that could undo it. And this kind of makes sense in life, right? Like, you always want to have an undo button for things. In math, you can have that for these operations. Cosine has the undo button, or the opposite operation, the inverse operation, cosine inverse. So here we go, a equals, and to put this on your calculator, you're going to do cosine inverse, which you can find in Desmos. Functions, go back to trig, clear everything out, go back to trig. And instead of cosine, make sure you don't do that. Functions, cosine inverse. And I talked too much and forgot the number. 0.5237. 0.5237. Well, of course it doesn't go inside of the parentheses, but here we go. 0.5237, close the parentheses. 58.42. So for the next one, we need to undo tangent. And of course, if there's a cosine inverse, then of course there is a tangent inverse that looks very similar. Tangent inverse on both sides cancels out tangent, and it gives us b equals tangent inverse of 4.56. Again, you're going to have to go to Desmos and do that. So functions tangent inverse of, wow, I have no memory for these numbers right now, 4.56. 77.63. Cool. Now, where this comes up is actually in a lot of geometry problems, and it comes up whenever we don't know the angle. But before we get to that point, we're going to start the next problem as though it were just a regular problem. So using the information given on the triangle below, determine the value of, this is a new symbol for us. And this is kind of like x for angles. So like usually when we don't know something, we call it x. If it's an angle that we don't know, we call it this thing. And the way that you pronounce this is theta. It's actually a Greek letter. You can recognize it because it's very similar to maybe your 9th grade production teacher's name, Thea, but it's theta. And we always use this as x for angles. So like when we don't know an angle, we just call it theta. It's like, I don't know how big that angle is, theta. I don't know how big that angle is, theta. I don't know how big that angle is, theta. All right, so here we go. Using the information given on the triangle below, determine the value of theta. Round your answer to the nearest whole degree. So we want theta. That's going to be our focus angle. Now, even though that's weird, we're going to hold off on that for a second because we know how to set up these problems that involve the sides of a right triangle. So we're going to label the sides. Hypotenuse, opposite, and adjacent, because this is opposite from the side that we wanted to find. Now we think so, ka, toa, and we're trying to avoid the hypotenuse because we don't know that one. So we cross out the two that have the hypotenuse. And it looks like the one that's going to relate our angle and our two sides would be tangent, and I think it does. So let's see if we can write our formula down. So the formula for tangent is always tangent of the angle. In this case, the angle wasn't a number, it was our unknown angle, theta, is equal to opposite divided by adjacent. And so here we go. We want to solve for theta. Well, it's a really good thing we had this conversation before, because to get rid of tangent, we just use tangent inverse on both sides. So we get theta is equal to tangent inverse of 15 divided by 16. And because this is all numbers and functions, you put that on Desmos and it will give you the answer. So here we go. Tangent inverse of 15 divided by 16. And the TI-83s all have the same functionality. So you can do that on those calculators, but you get 43.15. And if you think about it, that actually makes a lot of sense for an angle, because it's an acute angle, smaller than 90, and 43.15 is smaller than 90. So here you guys go. Again, you can follow along with the PDF that you're sent on Google Classroom or in your email. I don't really know how I'm going to get that to you, but you're going to have it as you watch this video. And you can do checkpoint 4 and checkpoint 5. Make sure you're using Desmos to do these. For problem 5, make sure that you start by writing your formula down, and then you undo that in these operations by using the inverse operations that you need. Finally, it would be really good to do problems 3 and 4 to complete your work, and then problem 5 is the tough stuff, so that's optional just like before. So I hope you guys found this video helpful, and you now understand how we can use sine, cosine, and tangent, because that is going to be what this unit is all about. And this is a topic called trigonometry. So I won't see you guys for a pretty long time. Hopefully this all works out and it's not too much of an interruption to your learning. So see you guys as soon as classes start up again.